Hello. Okay, you should see the desktop and you should hear me by now. Does everything seem okay?
Yep, looks good.
Okay, great, thanks. Okay, let me just get what I need ready. Okay, um, so what we're gonna do today is practice more using, well, we're gonna look at a different kind of loop today. The other day we did while loops and we did all these examples of while loops. Okay, and today we're gonna do another kind of loop called a for loop. Okay, so and after we do introduce for loops, next week we're going to do a really tricky topic called nested for loops. And you can see there's this reading here. This is actually one of the harder topics. It's actually one of the more interesting topics in the course. We can solve some really interesting problems with nested for loops. Okay, so let's start talking about. Oh, let's see. Actually, I suggested some problems on coding bat here. Uh, um, it's a good idea for you to practice using Java, and coding bat is really a great way to practice using Java. So these are problems in coding bat that almost all they use strings. Okay, they're not even for loop problems. I think all these can just be solved with using methods in the string class. So they're practice with using strings, but they're actually practice with just thinking about Java. Okay, so I these are I picked problems out of their long list of problems that I thought were the probably the best ones to do. So there's some suggested problems. Okay, those are good practice problems. And okay, so let's I'm going to open the Java visualizer and start talking about what's called the for loop. Okay, it's it turns out that for loops are just a kind of a more convenient way to write while loops. So it's not really a new idea, but it is a kind of a better way to write loops than while loops. In fact, most of the time we write for loops. We write for loops more often than we write while loops. Okay, so a for loop looks like this. You write for and then a left parentheses, and then the for loop's going to be broken up into three parts. There is a a variable part, okay? Then there's a test part, then there's an increment part, then you close the parentheses, and then there's the body of the loop, what you do, okay? So then there's the body of the loop, okay? Oops, I'm typing the wrong one, okay? Now, compare that to a while loop. A while loop look like while the thing you test, and then the body of the loop, what you do, okay? Okay. So there's these two kinds of loops. A while loop's real simple. It seems to have only just a test and a body. And this has got it seems more complicated. It has four things: a variable, a test, an increment, and a body. Whoops, typing these things wrong. Okay. Now let's do some. Now I'm going to make comments out of this because these are just keep them there to look at. They tell us how this thing should what they should look like. Okay. Now a simple example of a while loop is I want to say something like create a variable int I equals 0. Then I'll say something like while, here's the test, while I is less than 10, what do I want to do? I'm just going to print I. Okay, so there's a real simple loop. Okay, and I can run this. Okay, and oh, I'm sorry, I forgot something. Okay, I'm just printing out 0 forever here because I never changed I. So after I print I want to increment it. So I equals I plus 1. I want to make it grow. So I want to print I, then grow it, and then see if it's gotten to 10 yet. Without this, I was just saying I is 0. Well, 0 is less than 10, print 0. 0 is less than 10, print 0, and I had an infinite loop. Okay, so now by incrementing, now I'll be counting up. I'm going to count up from 0 to 10. Okay. And if I step through this, I can see that I'm just going back and forth. Follow the yellow lines because it's going to keep looping 19, 16, 18, 19, 16, 18, 19, 16, 18, 19. See, it's just looping. And down below, it's accumulating output. Okay. Okay, now let me rewrite this guy as a for loop. I'm going to write the same loop as a for loop. Because if you just remember I said there's variable, test, increment. There's variable, test, increment. Okay, so a for loop just takes this while loop and bundles it up into one thing. So that while loop would look like this: for int I equals 0. That's the variable I want to loop on. Then here's what I want to test on it. While that I is less than 10, after I do an iteration of the loop, how do I want to change I? I want I to be equal to I plus 1. And then what do I want to do with each value of I? I just want to print it out. Okay. Okay. This and this act exactly the same way. There are slight differences between them. There is going to be a slight difference between them. Okay. Now, for example, one problem is that Java warns me that I've already used I. Okay, see, I used an I up here, and I can't kind of reuse it down here. So what I'm going to do is I'm going to change this one to use the letter J. Oh, I'm sorry. Okay, so I'll change this one to use the letter J. Okay. 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 Now the while loop is going to loop 10 times. We can see the output accumulating down there. Okay. And then the for loop is going to do the exact same thing. Okay. This is just going to loop exactly the same way, do the same thing again. Okay. What it does is it starts out with this variable. Actually, go back over here. The for loop does pretty much exactly what this thing did. We'll see there's a tiny difference between, there's a couple tiny difference between this and this. But essentially what the for loop does is says, start with an I that's 0. Check that it's less than 10. Then go down here and do this body. Then go and make the increment. Then go back and make the test. Okay, the loop is between here, here, and here. This thing is only done one time. Just like up here, that was done once. It created our variable. Then we tested it. We were actually less than what we wanted it to be. Then we started the loop. Notice that after we did this, the last thing we did was this increment. Then we went up and tested it again, then printed this, and then did the increment. Down here, it'll be test it, print it, then do the increment, then go back and test it. And you only have, this one's only done once. Okay, so this is the pattern for a for loop. Now, here's I'm going to draw a picture to show you. Let me draw a picture. Here's a, here's how you should think about a for loop. Let me write out a for loop. For, let's see, make it even bigger. See if I can make it bigger. So it's for, we have the variable part with a semicolon after it, then the test part with a semicolon after it, then the increment part. Okay, there's no semicolon after the increment part. Then you close the parentheses. Then there's the body. Okay, and then close it. Okay, now here's how, when you make this part of a program, when you make this part of the program, here's how the program flows through a for loop. Okay, so the program would come in and it would go to the variable part first. The program will come in and go to the variable part, does that first. Okay, then after the variable part, you go to the test part. Okay, now if the test is true, you go to the body part. After you do the body, you come back up here and do the increment part. And after the increment's done, you go and do the test again. Okay, and then here's the loop right there. The loop is test, body, increment, test, body, increment. You never go back to this guy. Now, when the test fails, when the test is false, so this was the true part. When the test is false, then you leave. So you leave when the test is false. Okay, so that would be the false part of the test. The false part of the test takes you down here, out of the loop. Okay, so you stay in the loop as long as this thing is true. While this thing is true, you stay in the loop. Then when this thing becomes false, you go to the next line of code. So this is coming in from the line of code just before the for loop. The for loop starts with variable, then it does tests, then it goes to the body, then it goes to the increment. Okay, now if I, let's see, let me save that. Okay, you can kind of watch that happen over here, but let's go to the visualizer again. Okay, I'm gonna I'm gonna comment out. I don't want to do the while loop this time, so I'm gonna make the while loop a comment. Okay, and I want to just do the for loop. Now, this is one of the places where the visualizer is helpful, but there's a little bit, it doesn't show you this picture very well. It doesn't show you what's going on over here very well. So let's watch it. Okay, so our program now is at line 23. We're actually at the variable part. If I step one step, now you see I'm at step one now. I step one step, I'm at step two, but I'm still at line 23. What I really did is I just stepped from the variable part to the test part. Okay, I just stepped from variable to test. Now, it doesn't show you that here, but I'm actually at step two is the test. Okay, the test is true, so now step three, well, actually, step three, I'm still in, let's go back and let's see. I don't even know what step two is. Step three, see, created I. See how I created here? So step three was that, okay? Oh, I'm sorry. We're about to do step one. Step one, I think, is just entering the for loop. So I think to them, step one is we enter the for loop. We're about to do step two. We're about to do step two. Doing step two creates I. Now we're about to do step three. Step three is the test. So the test is, yeah, I'm not sure what their step one was. I think step one was kind of just uh, getting to the for maybe. Okay, so, but in their ordering, step two was doing this. Step three is doing this. We're about to do step three. Okay, and when we do step three, we're going to find out this is true. So now this is step four. Do the print. Now we're back up here. Now step five, we're about to do step five. That's really this one. Okay. Now watch. When I do step five, I'm over here, and see I changed. If I go back, step five is over here. Now notice that step six is still on the same line, because step six is now I went from increment back to test. So now I'm back here, and I'm about to do the test again. Okay, so step six is the test again, and the test is still going to be true. So now I'm down in here. Okay, so now I'm down here. Now I'm over here. Click forward. Now I'm over here. Okay, click forward. Now I'm back in here. Now notice that the Java visualizer doesn't show you where you are in these three parts, but we can trick it into doing that. So watch, nobody ever writes their code this way, but watch, here's a trick I can do to make it show me the steps. Put that on one line by itself. Put that on one line by itself. And put that on one line by itself. Nobody would ever write code this way, but it's kind of a neat trick. If you do this trick, the Java visualizer shows you this pattern here. It shows you very clearly now. It'll show us that pattern there. Okay. Java doesn't really care how you format your code. Everybody would write a for loop this way, but Java doesn't really care how you format your code. So you can write your for loop any kind of way you want. Okay, so here I'm just breaking up the three parts under each one on a line by itself. Okay, now let me visualize that. Okay, so here notice now it says step one, I'm about to do that. Okay, and actually notice that step one didn't seem to do anything. I don't really know what they're counting as step one here. Okay, because step one, I thought, well, step one would be here. But no, they made step one here, but it doesn't do anything. Okay, okay, step one doesn't seem to do anything. Okay, now, so what's important is now step two creates the variable. Next step, tests it. But see how we jumped from the test to the body. See, we jumped from the test into the body. Okay, now print. Okay, and see how we jumped from the body up to the third part. We jumped from the body over to here. We went from if we back up, okay, we went line 24. We went from line 24 to line 25 to line 28 to line 26, then back to line 25, okay, back to line 25, then to line 28, okay, then to line 26. There's kind of a funny thing here. Line 26 is taking 2 clicks. Not sure why. Yeah, it's not always clear how they're doing this, but line 26 is taking 2. So here I'm at line 28. That's step 8. Step 8 does the print. Step 8 will do the print. So you see something print at the bottom. That was step 8. Now I'm going to need 2 steps, 9 and 10 at 26. Step 9, step 10. I think possibly what they're doing is step 9 is adding 1 to I, and step 10 is storing the result in I. Okay, so if I go back to here, I is 1, and I print 1. Okay, now I'm up here. Okay, well, I can see 2 steps there. There really is 2 steps there. I need to add 1 to I. 1 plus 1 is 2. then I need to store 2 back in I. Okay, so one step here could be adding 1 and then storing it. Okay, okay, so it took 2 steps. Okay, go back. There's the print line. That's step 8. Okay, step 9 and 10 were both this line. Okay, and then now I'm up here. Okay, I'm about to do step 11. Okay, and so now I'm going to loop from here down to here, back to here, then here, over here. And I never go back up to this line. You only do that one time. So the loop is now in here. Okay, so now remember, normally if you're stepping through code in a for loop in the visualizer, it doesn't show you the difference between the usual way to write the for loop I'll put it back the way it should be. The usual way to write the for loop, like that, you put these things in one line. When you're stepping through a for loop the usual way, the Java visualizer won't really show you whether you're in this part, or this part. It doesn't really show you that. So you have to kind of think for yourself about that. And it's actually real important to do that. When you're writing your own code and you're studying your own code, you have to really think when you're figuring out, like, if something's wrong with your program. You have to analyze what a for loop is doing. You have to remember that it goes that first, then there, then back. Notice you don't read it from left to right. Like a real, we're going to see this more and more. You don't read programming code from left to right. You can read programming code in all kinds of funny ways. Sometimes it's read from left to right. Sometimes it's read from right to left. Sometimes you kind of bounce around. Like here, it's read 1, 2, 3, 4, 5, that order. And if you want to think about what it's doing, you can't think. And like it would be wrong to say, well, what this code does is sets I to 0, then it checks if I is less than 10, then it adds 1 to I, then it prints something out, then it goes back and sets I to 0. So you wouldn't read it in a, even if you thought it was a for loop and you thought, okay, I read it in a circle. I go here, 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 here. That's wrong. Even if you thought, okay, oh, I only do this one time. So what I do is I do this one time. Then I do here, 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 here. Well, that's wrong. If you loop like that, there, you'll be thinking about it wrong, and the code will do something different than what you think it does. If you think it goes here, 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 you'll write it one way, but then it'll run a different way. It doesn't go here, here, here. It goes, remember, here, here, then back here. The loop is, instead of the loop being clockwise like this, the loop is actually counterclockwise like that, from here to here to here. See, the way it is, it's a counter. See, if you think of it pictorially, it's counterclockwise, not clockwise. Okay, and that makes a big difference. The program won't run the same. Those are two different ways of running the program. Logically, it makes a difference whether you do this, this, and this, or if you do this one, and that one. So they're not logically the same thing. So you have to know how this thing is read, that it does this one time only. Then after it's done that, then it does this. Oh, and if this thing is false, the loop may not loop at all. The same thing was true of while loops. The while loop doesn't actually have to loop. So for example, if I write this loop here that I is less than 0, like this, I make a little typo. Okay, I is 0. Is 0 strictly less than 0? No. So if I visualize this, that loop doesn't loop. Okay. Okay. It starts off, sets I to be 0. So I just did that part. I'm about to do this part. Okay. And it figured out that that this was false, and it immediately jumped me to the next loop. You notice that this guy did not loop. Okay. So I started in here, I'm at the beginning. I went from line 23 all the way to line 29. I never looped at all because this thing was false right at the beginning. While loops are the same. They don't actually have to repeat anything. They may, or you might think of it as they repeat it 0 times. In this case, it repeated 0 times. Okay. And if I want, I can repeat just 1 time. This will do 1 loop. Okay. Okay. Set I to be 0. 0 is less than 1. I print out 1. And then I go back up here and I'm essentially done because 1 is not strictly less than 1. So I only looped 1 time. Yeah, it's the same thing as if I did this thing 1 time. So it wasn't really a loop. I did this 1 time. Yeah. So while loops and for loops don't have to be loops. There are times when they just do something either no times or just 1 time. Okay. Now, let me show you a weird quirk in this. It's a subtle little detail. I'm going to put back the while loop. Okay. Now, remember I had an I here. I'm going to go put back the I. Okay. Now Java's going to complain that I've got an I here and an I here. So Java's going to complain about the second I. Okay. Now watch. If I take this loop and I remove it from here and put it in front of this one, I've got an I here and an I here, but this one's not going to complain about it. Okay. It's not going to complain about that I. It will complain about that I, but what? See, complain about that I, but this one's okay. Yeah. So why? Yeah, if there's an I here and an I here and an I here, why does it complain about this one? Okay, so here's the detail is this. This I is inside that for loop. So when you leave the for loop, this I doesn't exist anymore, so there's nothing to complain about. Okay, the I is inside the for loop. The word for that is its scope. This I is outside the while loop. So this I actually exists for the whole program all the way down to here. But this one down here actually conflicts with this I. This I is what Java's complaining about is this I is a conflict with this I, not with this one, because this one disappeared here. So for example, if I move that loop now here, now there's no conflict. This I lives inside of that loop. So once the loop is over, that I is gone. Java doesn't worry about it. This I lives in that loop. So once this loop is gone, the I is gone. Now this I is by himself and there's no conflict anymore. So now this one's okay. Okay, see? All right, so that's one difference between for loops and while loops. A for loop can have its variable inside of the loop. While loops can't do that. You're not allowed to say something like int I equals 0 inside of a while loop. Okay, no, that doesn't work. Now, on the other hand, you can make the for loop act more like a while loop. I can do the following. I can do int I here. Then I get rid of that int. Okay, so now this I lives inside the for loop. This I is outside the for loop. So it goes all the way down to here. Now it conflicts with that I there. But I can fix that by just saying, well, okay, now I'll compile this. That I is the problem because it repeats that I. You can't have the same variable twice. Okay. Now remember, that I is fine. Okay. This I now extends all the way down to the end of the program. But I can just fix that by saying, well, set I back to 0. This I is now that one. It went from 0 up to 10 here. It's going to go from 0 back up to 10 here. But I can just reset it back to 0, and now Java's happy. I only have one I at a time. You're only allowed to declare one I at a time. Okay. Now, in a while loop, your variable has to be outside the while loop. For a for loop, your variable can either be inside the for loop or outside the for loop. Most of the time, you put it inside the for loop. Sometimes you want it outside the for loop. We'll see as we go along why that would be. It'd be hard. There's no real hard and fast rules about this. Usually, if you can put the variable inside the for loop, that's where it belongs. But if you find it has to be outside the for loop, then that's where you put it. So most of the time, your variable will be inside the for loop. Every once in a while, you will see you need it outside the for loop. Okay? While loop, the variable has to be outside the while loop. Okay? And this is one of the better things about for loops. So one of the nice things about for loops is when I put the variable in the for loop, I can just have I don't have to worry about, oh, this one was an I, so I got to make this one a J, and I got to make this one a K. You don't have to keep coming up with new variables. As long as you can put the variable inside the for loop, and if you have multiple for loops, you can keep reusing the variable, which is very convenient. In older programming languages, it was a real nuisance. If you had 3 for loops, you'd have to have a letter I for one for loop, maybe a different letter for the other for loop, and a different letter for the other for. And we'll see that we still need that when we do something called nested for loops. When we put for loops inside of for loops, then we will need lots of variables. Okay, so we will eventually get to something we call nested for, like we had nested if statements. We'll have these nested for loops. Okay, all right. So far, this is all just the mechanics of for loops. What's really interesting is to see what we can do with them. Okay, so this is just the basic idea of a for loop. Okay, and this is the picture that kind of explains it. Okay, let's look at like playing around with for loops where we could solve some problems with them. Okay, so now when would you really? Oh, here, why do we have two kinds of loops? While loops and for loops. Roughly, we use a while loop. Here's kind of the rough rule. You use a while loop okay. Roughly, you use a while loop when you do not know how many times you will loop. And roughly, use a for loop. So this is use a while loop. You use a while loop when you do not know ahead of time how many times you're going to loop. And you use a for loop when you know how many times you want to loop. For loops are sometimes called counting loops. Okay. If you know how many, if you want to count from one thing to another thing, like if I want to count from 0 to 10, okay, that's a for loop. That's a good example of a for loop. This was oh, I put the comment. I'll put the comment up here. Okay. So use a while loop. This idea when you don't know how many times you're going to loop. Use a for loop when you know. And here's the counting would be in here. You set your variable to its start and you test it at the end and you increment usually by 1. We'll see, you can actually increment by other things, but we'll usually increment by 1. So we think of for loops as counting loops. Like this is counting from 1 to 10. This is counting from 1 to 10. This guy's counting from 1 to 10 also. So this really should have been a for loop. Now, go back to what we did yesterday or the day before. Let's go to one of the examples we did. There was one example here that's a classic example of a while loop. I think it was 3. Let me see if I remember right. Yes. This is a, a perfect example of when you should use a while loop. This program would ask a person to enter a positive number. Then it would read their number. Now you ask them for a positive number, but you have no control of what they type. So you check if they actually gave you a positive number or not. If they didn't pay attention, you print out, please enter a positive number. You read their number, and then you check it again. How many times are you going to loop? Well, how dumb is the person at the computer? So you don't know how many times you're going to loop. You may not loop. If the person gives you a positive number right away, then you loop 0 times. See, if they gave you a positive number, this would be false and you wouldn't even bother to loop. But if they were stubborn and kept typing negative numbers, you'd keep looping. So this is a classic example of a while loop. I don't know how many times I'm going to have to loop before the person gives me what I want. Okay, so that's a good example of when a while loop's the perfect thing. Now let's look at one of our other examples. Not that one. So it was, say, 5. Okay. Remember, this one took the string and printed it out vertically. Okay. But this one, I know exactly how many times I want to loop. I want to loop through the steps of the string. This would be a good example of something that really would have been better as a for loop. So that's where we're going to start. We're going to take this one and turn it into a for loop. Notice that it's got the pattern of a for loop. It's already there. There's the variable part. There's the test part. There's the increment part. Notice that it's actually laid out exactly like a for loop should be. And it becomes easier to read when it's written as a for loop. So the for loop is going to become an easier way to read this. So let's go ahead and let's take this one and change it into a for loop. Because this one we shouldn't change into a for loop because we don't know what to count up to. Yeah. So here the idea is that I'm just going to say, while they still give me a negative number, do this. While they're giving me a negative number, I keep doing this. How long am I going to do this? How long does that person want to type in negative numbers? Okay. So I don't know how many times I'm going to loop. But this one, now I change the word while to for, take this part here, move it from there into there, and take this part here and move it from there over to here. And now it's a for loop. And now it's easier to read. I'm going to step the index variable from the beginning of the string up to the end of the string. And I'm going to step by 1. And this part here, this is where these plus operators are really useful. You can make this even a little bit easier to read by writing I plus plus. Yeah, this is what it was actually kind of invented for. The plus operator makes for loops even a little bit easier to read. Instead of me reading, well, I'm going to take I and set it equal to 1 more than I and having you think, okay, that increments I by 1. It's just nicer to write that as I plus and say, now everyone's real used to reading that as increase I by 1. Okay, so now I say start at the beginning of the string, go up to the end of the string by 1s. Okay. Now, if I wanted to, I could go back and do this and go up by 2s and actually print out only every other character in the string. Yeah, and sometimes you want to do weird things like that. So the increment part doesn't have to be by 1s. The increment part can be by anything you want it to be. And now I would be printing out every other character in the string. But I want to print out all the characters in the string. So I'll do that as I plus plus. Now visualize it. Okay. And it does the same thing as the while loop did. It printed out the string vertically. Okay. All right. So So that's the classic way of thinking about these. Use while loops when you don't know how many times you're going to have to loop. Use for loops when you want to essentially count across something or count up to something, or we'll see count down. In a minute, we're going to do an example where we want to count down for something. But when you're essentially counting something, stepping through something, for loops are easier to read. Again, you can write them any. One thing that's true in general is that any for loop can be turned into any while loop you write can be rewritten as a for loop, and any for loop you write can be rewritten as a while loop. Okay. In fact, that's not quite 100% true. Every while loop can be rewritten as a for loop. When you write a for loop back as a while loop, there's one little weird thing. Because that variable is inside the for loop, if you rewrite it as a while loop, the variable has to become outside the for loop. That could cause you trouble because then you could end up with too many of that variable. So it's not, every while loop can be turned into a for loop, but it's not quite 100% true that every for loop can be turned into a while loop. If you do convert your for loop into a while loop, you may have a problem with your variable name. Okay, so but essentially from roughly we say that while loops and for loops are equivalent. You could write all your code in while loops, you could write all your code in for loops. And in fact, of the two, for loop is used more often, and there are people who do only use for loops. Okay, like I'll show you. Here's a weird little trick. This is legitimate in Java, but it's not really recommended. That's a while loop in disguise. If you leave the variable part empty, see, you're allowed to do that, an empty variable part and an empty increment part, then this is exactly a while loop. It just does, you just change the word while to for, and you've put this empty thing in front of the test and an empty thing after the test. So this is a while loop. So every while loop can be turned into a for loop by turning the word while into the word for and putting the test in the middle part and just having an empty part here and an empty part here. So some people use for loops all the time. And if they really meant to write a while loop, they write it this way. Okay. You'll see people do this stuff all the time. You're allowed to make these parts empty. In fact, you're even allowed to make that part empty. That's an infinite loop. That loops forever. And there's people who write it that way. There are reasons to write a loop like that. There actually are good reasons to have a loop that loops forever. And we might see some examples every once in a while. But that's a legitimate piece of Java. It's not a legitimate piece of Java to write an empty while loop. That's not legitimate. Java will not compile that. You have to have the test in there. But with the for loop, they let you do that. They let you have a for loop with no test in it. Okay, and we could actually take that and you can just see here. Go to the. I'll open a new visualizer. There's my empty for loop. I'll make the body. I'll just say I'll print hello. Now, I can't really run this in the visualizer because this guy's an infinite loop. So it's going to loop forever. The visualizer is not going to like that. So let me actually take that and put it in the Dr. Java, because Dr. Java doesn't have a problem with infinite loops. Okay. There's my program with an infinite loop in it. Okay. Save it on the desktop. Compile. Notice it's legitimate Java. See, and sometimes people would even abbreviate. Yeah, if people are writing this kind of thing, they might even just write it that way without even any, just write it like that. Okay, see, that's still legitimate. And then if I run it, runs forever. Okay, if you wanted to, okay, remember reset stops that. You could put the word false here. I'm sorry, you could put the word true here just to make it, some people putting the word true there is more or less your way of saying, yes, I know this thing's an infinite loop. Yeah, I'm going to loop forever on true. Okay. But most programmers won't even put the true there. They will just leave it empty. If you want an infinite while loop, you write while. Here you have to write true. Okay. Now I won't ever get to this while loop because this one's going to run forever. Whoops. Oh, and Java actually figures that out. Notice that the compiler, this is actually kind of the Java's kind of smart about these things. It realized that this thing never stops, and it says unreachable statement. You never get to there. So it figured out that that thing never stops. So if I want to show you that that loops forever, notice I have to write the true there. I'll just comment this one out. So I'll remove this one from the program. Okay. This one doesn't need the true in here to be infinite. This one does. So now compile. Okay. And that still is an infinite loop. Okay. And as we over time, we'll see when it would be. Why in the world would you ever write something that's going to run forever? And we'll see examples where that can be useful. There are times when if you look at real code out there in the real world, you'll see this pretty regularly, and you'll see or this pretty regularly. They're the same thing. You're not required to write the true for the for loop. You're required to write the true for the while loop. That I should show you that that one won't compile. See, that one won't compile. You illegal, you cannot have an empty while statement. Okay, so true makes it run forever. Okay, so there's the two ways to write infinite loops: with a for loop, an infinite for loop, or an infinite while loop. Okay, all right. So again, the the key idea is use a for loop when you know how many times when you know ahead of time how many times you're going to loop, and use a while loop when you don't know ahead of time how many times you're going to loop. And since I just said that you could use one or the other either time. Any while loop can be turned into a for loop, any for loop can be turned into a while loop. So what you're doing is when you choose to use a while loop, you're essentially helping the person read your program. By choosing to use a while loop, you're kind of saying to them, we don't know how many times this is going to loop. If you choose to use a for loop, you're kind of helping the person who's reading the program. You're essentially saying, here's how many times this thing's going to loop. Okay. Now that's not 100% true, because I just showed you that someone could write a while loop that loops forever, and they can do so. And if any while loop can be turned into any for loop, that's not a 100% true statement. But what most programmers do is they use a for loop when they know how many times it's going to loop, so that when the reader looks at it, they can say, oh, now I can look at the way the for loop is written and see how many times it's going to loop. If the programmer chose a while loop, it's usually saying, I don't know how many times this is going to loop. I don't know how many times a user is going to give me a negative number before they finally give me a positive number. There's no way I can know that. So I would use a while loop for that. Okay. All right. Now let's look at some examples of doing more interest. Okay. All that's the mechanics of while loops and for loops. Let's look at just some like puzzles, problems you could do with them. Okay. Like here, we printed out a string from top to bottom. Okay, what if I want to do that in the opposite order? Let's do that one. Let's reverse the string. Let's print out the string in the opposite order. So I want to keep that and open another visualizer window just so I can keep the old one and not lose it. And want to think, how can I change this so that I'm going to print it out backwards? Okay, right. So what I'm going to do is I'm going to start with I at the end of the string, and I will decrease the I and step through the string from back to front. Okay, now watch how I can do that. Here's the length of the string. So I can start I like that, except I can't start I with that. What's wrong with starting I with that? That's kind of dangerous. What's wrong with I equal s dot length? Like this string here, its length is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 characters. Okay, now there is index 12. What about index 12?
So you need to add one more value at the end?
Well, no, there, my string is HELLO space THERE period. It's got length 12, but what about index 12? Is there anything there?
There's a, you're talking about the period at the end, or?
Pardon me?
You're talking about the period.
Here's a string. The string has length 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 characters in the string. The H has index 0. The E has index 1. That L has index 2. That L has index 3. That O has index 4. What about index 12, which is S1 dot length? What's there? What's at index 11? In this string, what is at index 11?
No, 1.
Pardon me?
Oh wait, the string. No, I was looking at the numbers. My bad. Sorry, I got me confused. But it's that string. You said at index 11, right?
What's at index 11 in that string?
Period.
The period, right? The period. What's at index 12?
Nothing, right?
Nothing. There is no index 12. So that would be a mistake to try to use index 12. There is no index 12 in the string. Now 12 is the length of the string, but because we started it counting at 0, there's no character at index 12. The last character is at length -1. The last character is at length -1. So that's where I want to start my index. I want to start counting down from 11. Okay. Now, when do I want to stop counting? When I get to 0. So as long as I is greater than or equal to 0, I keep counting down. So I want I to be greater than or equal to 0. I want to count from 11 down to 0. And I want to decrease I. Okay. So here's an example of a loop that's a little bit harder to write. Okay. The loop is going to start at this end of the string. And so that's s dot length -1. Oh, I could just put 11 here, right? I started index 11. Okay, now visualize execution. See, now if I look at the output, it printed the string out backwards. Okay. What's wrong with putting 11 there? It's not really wrong. What's not good? What's not great about putting the number 11 there?
It could be, the string can be less than 11, right? Somebody writes.
Well, I could put any number I want there. Like suppose I put the number 5 there. What will that do?
Print out O.
It'll start at O.
Oh, yes, sir.
And then do what?
And then go backwards, right?
Go backwards.
L.
So it'll print out O-L-L-E-H. Okay. That'll print out O-L-L-E-H. O-L-L-E-H. Okay. What if I put 15 there?
Will it give error?
Where will it will it compile?
I'm not sure.
Oh, it compiled.
Okay.
Will it be an error? What's going to happen when I try to start stepping through this program? What happened?
It's out of range, right? There's no 15.
Yeah, there's no 15th letter. So it's out of the range. There's no 15th letter in there, actually 16th letter. If the index is 15, I'm looking for a 16th letter. Okay. All right. So I can put any number I want here, though some numbers are good and some numbers are bad. Okay. What is the good thing about writing that? Why is that a good thing to write there? As opposed to writing 11. They right now they do the same thing. Writing 11 there will step me from here back. That also will too, but this is way better. Maybe what's logically, why is this a better way to write the code? What's an advantage of it?
One of the advantages could be of like strings that you don't know the length of because they can be like super long, or something that can be like a variable, like an array.
Yeah. So exactly, the idea is that what if somebody's going to give me that string, or I'm going to read it out of a file somewhere, and I don't know how long it's going to be. For example, I just change it now. Does the code still work?
Yeah, so you'll never get error, right?
Right. Now, what if I had put, now, okay, there's my string I started with. There's 11. Works fine. I give it to my boss. And he goes, I don't like this very much. And he goes, because what's wrong now?
It doesn't work properly because it's starting in the middle of the string.
Yeah, now it's starting in the middle of the string. Even worse, what's wrong now?
It's out of bounds.
So it crashes. Okay. Now so if I give it to my boss like that, and I say, hey, it works fine. And he goes, that's not very acceptable because it works fine right now, but if I do this, it doesn't print out the string backwards. It only prints out part of the string backwards. And if I do this, it crashes. On the other hand, if I go back to s1.length -1, now I got works now, works now, works now. And if the string gets read out of a database, it'll still work. Now this loop prints out whatever's in that string backwards from the far end to the beginning. That's important. Yeah, see, now this works for any string that I put up here. Okay, so again, you can, if somebody gives you that string and says print it backwards, you will have solved the problem if you put an 11 there, but you won't have solved it a good way. You'll have solved it a way that's, word we use is brittle. It works okay as long as the string stays like that. Okay, as long as that string stays 11 characters long, you're all right. As long as that string stays 11 characters long, somebody changes it, you're okay. But if they change the string to be shorter or longer, then this is not okay. Okay, but it's easy to make it okay by just saying s1.length -1. And you got to be careful though. If you do that, it's buggy. Okay, there is no character at, remember, this number is an index off the end of the string, so this is always going to crash. If you type this, it'll always crash. You have to start it at -1. And the length of the string -1. Okay, now let's make this, okay, now let's take this, now this one prints the string from top to bottom backwards. Now let's make the program a little bit more interesting. Let's create a reversal of this string. So let's create, I'm gonna make a copy of this in another Java visualizer window. And the problem now is, instead of printing it out backwards, can we make a string S2? I want S2 to hold this string backwards. This is a little bit even hard. It's roughly the same thing, but a little bit trickier. I want S2, so I'm going to do the following. I'm going to make S2 an empty string, and I want to fill it in so that when I'm done, I'm going to go down here, system.out.println S2. I want S2 to print out S1 backwards. Okay, so actually, I'll print them both out. So I'll go down here at the end. I'll print out S1, and I want S2 to be backwards. So now the question is, what do I do in here? So this is not what I want to do at all. I don't want to print it out backwards. I want to build S2 so that it holds the backwardsness of S1. So then when at the end, I can print out S1 and print out S2, and they'll be reverses of each other. Okay. Okay. So let me show you. So here's what I'm going to do. This thing, when I'm stepping through here, I'm pointing at, I points me at the last character in the string. So my answer, oh, here, I can write out my answer. I want my answer to look like the following. I want it to be .EREHT space OLLEH. Okay, that's what I want it to be. Okay. The I starts here, which is what I want at the front of this guy. Then the I goes to here, and I want that next in this guy. Then the I goes to here, and I want that next in this guy. Notice that as I steps through the string, what I want keeps getting put at the end of the string. Okay, so notice that as I step backwards through this string, I'm stepping forwards through this string. So here's what I'm doing. I'm making S2 equal to what is in S2 already plus S1 dot I. Well, S1 dot char at I. Okay, it's a little bit tricky. Okay. S1 dot char at I is going backwards through here. So it's this guy, then this one, then this one. Okay. And notice that as I go backwards through here, I want to put them at the end of this string. So first I want to put the period at the end of this empty string. Then I want to put the E at after the period. Okay, so whatever S2 is holding, I want to take the next character and put it at the right end. Okay, and then make that the new S2. Okay, I can't just do this. That will give me a new string and then throw it away. That will take this string, add this to it, and throw it away, and doesn't save it for me. So I need to say, now take that answer and put it back in S2 so that S2 holds the new string. This is tricky because a lot of people would think, I just need S2 with that character at the end of it. And that does build S2 with this new character at the end of it, but I want S2 to become that new thing. So I have to say S2 equal. Okay, now let's watch this, see if it works. Okay, let me just go to the end. Okay, see, it worked. I got S1 is hello there, and S2 is backwards. Okay, but let's watch it run. Okay, so start with S1 being hello there. Notice I'm letting the visualizer show me this the wrong way. Remember, the right way is that this should be out here in the objects, but right now it's showing me the wrong way. It's showing me this is a string inside the variable. The variable, remember, it's real important. It's really an arrow pointing at the string. The string's out here. The string should be out here. And I could, if I wanted to, I could have Java Visualizer show it me the other way by going over here and checking that box. I'm gonna leave it the way it is for now. But let's just watch and see if it makes a difference. And that sometimes in many programs, it doesn't really make a difference which way you show the strings. Okay, so there's my hello there. There's my S2. It starts out empty. Okay, I'm going to start out I at 11 because I want to start at the end of the string. Okay, now go forward. Okay, now notice I put a period on S2. I just did that line there. I did, see if I go back, I'm about to do line 11. A line 11 is going to take the empty string, add on the period to the empty string, and then make S2 a name for that new string. So I get that in S2. Then I go back up here and I decrement I to 10 because now I'm going to move from the period to the E. Okay, so I moved to the left. Now I'm going to check whether I've gotten to the left end of the string. So now I'm actually going to go from the increment part to the test part. So now I'm going to go to the test part and I find out I'm still not to the left end of the string. And now I'm going to take S2, which is a period, and put this E on the right of the period. Okay. And then I'm going to keep doing that. And I'm building up the string backwards. Okay, see how it's building up backwards. Okay. Now, here's something interesting. What if I reverse the order of this addition? What do you think that's going to do? Let's go through it. S2 is the empty string. We start off here pointing at the period. We take the empty string and put the period on its left, which makes this string the period. Then we step to the E. Then we go through and take the period and put the E on its left. Then we go to the R. And we go here and take the E period and put the R on its left. What are we building? What's S2 going to hold when we're done?
So it's gonna be back in correct order?
It's going to be back in the correct order. Yeah, it's not reversing it now. Yeah, exactly. It's going to be S2 is going to be S1. Now let's watch it happen. Okay. Okay. Here's S2 is the empty string. I put the period on it. Now I'm going to put the E to the left of the period. Now I'm going to put the R. See, the index is 9, so I'm at the R. See, index 9, R. I'm going to put the R to the left of what I have so far. Okay. Now I'm going to decrease to 8. 8 is this E. I'm going to put that E to the left of what I have so far. And if you watch, I'm building up the string backwards, but in the right order. Okay, so I'm building up the string backwards in the right order. All right. Now, notice that this was tricky to read. Okay, this loop built the string up backwards, but in the right order. It built it up from this end going that way, but built it up in the right order so that S2 is the same as S1. Okay, if I, so let me just real quick show you show you a bunch of different things I could do here. I'm going to make copies of this loop. Here's one copy of it. Here's another copy of it. Oops. Okay. In this copy, I'm going to, here's our first one. In this one, I'm going to reverse the order. In this loop, I'm going to loop across the string from left to right. So I'm going to loop from 0 up to I strictly less than S1 dot length. And I'm going to increase my way up through the string. Okay. And then I'm going to do the fourth one. Look like this. I'm going to move up the string, but I'm going to put the S2 at the other end.
I found that I never fell for a lie. You might want to keep that kind of thing.
Okay. Here's a puzzle. We run out of time. The puzzle is, what do these 4 different versions do? So there's 4 versions. There's version 1, version 2, make it a little bit easier to see them, version 3, and version 4. Okay. So now we run out of time, but what they if I visualize it and just go to the end, you'll see, oh, what did I do wrong? Oh, I forgot the parentheses at the end here. And I need them here too. Sometimes let's see. Oh, I need to set S2 back to empty before I do each one of these. Before each of these, to make this work, I need to make S2 empty again, then make S2 empty again, then make S2 empty again. I have to empty out S2 before each one of those loops. And the puzzle is, what do these different loops do? Sometimes they reverse the string and sometimes they don't. Okay. Sometimes the string gets reversed and sometimes it doesn't get reversed. Like this is S1, S2, S1, S2, S1, S2, S1, S2. Notice that twice it reversed it and twice it didn't reverse it. Okay. And the question is, how do these things work? Okay, this is what we'll start off with next week. But this is a real good example. By the end of the semester, one of the goals is that you could take a loop like any one of these, like take that one and read it and say what it's doing. Like it's stepping through the string from left to right, but it's building up this new string on the right of S2, whereas this one's building up the new string. Oh, yeah, on the, this is putting the new stuff on the right of S2. This puts new stuff on the left of S2. This moves through the string from left to right. These move through the string from right to left. This moves through the string from right to left. This puts the new stuff on the left. This puts the new stuff on the right. This puts the new stuff on the left. Move through the string from right to left, put the new stuff on the right. Move through the string from right to left, put the new stuff on the left. Move through the string from left to right, put the new stuff on the right. Move through the string from left to right, put the new stuff on the left. 4 different ways of doing it. And you should be able to think your way through what all these 4 different things are doing. It might seem tedious, but this is what programming is about. This kind of, being asked what does this do versus what does this do is typical of the kind of questions people ask these days in job interviews. This is exactly how people test each other in programming. They say, can you tell me what this thing does? Can you tell me why this one's different? Okay, because this is exactly what programmers do all day, is write code like this with subtle little differences like this. So these problems might seem kind of picky or tedious, but they're not really. They're what programmers think about all the time. And I can guarantee you this is exactly the kind of question that people ask in job interviews, especially like for internship, not professional programs, because these are actually too easy, but like for an internship, they would ask questions like this. If somebody's still a student, like if somebody's a sophomore in programming and I was going to interview them, I'd ask them questions like this. Can you tell me what this loop does and why this loop is different? Because that's what the level you're at now. You're learning to read these kinds of loops. By the time you graduate, you'll be reading much more complicated loops than this. But right now you're learning to read and understand simple loops like these. Okay, so we've run out of time. So we'll quit here and do these coding bat problems. This is where you get the most practice with actually thinking about Java. I'll give you another programming assignment soon, but these are small problems. You should be able to do one of these an evening. And that's actually what you should think about. You should be able to, it should take you like half an hour to do one of these. Once you're good at them, you can usually do them in 5 or 10 minutes. If you get to where you can do one of these in 5 or 10 minutes, you've really learned this stuff. You should be able to do each of these in say half an hour. You should do like one an evening. That's where you learn programming. Coding Bat was designed as a way for people to really practice doing programming. Okay, so I'll put these examples we did up on the course website so you can look at them. And if you have questions about any of this stuff, please come to office hours. If you have questions about these Coding Bat problems, if any of them, if you can't figure it out or you want to ask a question about them, you can ask me in office hours or by email about the Coding Bat problems. Okay, so we'll go ahead and quit there and have a nice weekend. And we'll do more loops. We'll do loops again. Next week we'll still do more loops. Like we're going to do the hard ones. The nested loops are going to be really the hard loops that we're going to be doing. Okay. Any last question? Anybody have any question before we leave?
Thank you.
Okay. So have a nice weekend. Bye.